Hey Geometry, we're starting chapter 12 and this will be the last chapter of the year. So we'll try to take it slow, about 2 lessons a week, because it's a lot of new information and you'll want to try to understand it because a lot of this will show up on your ACT next year. So I have notes for chapter 12 digitally on Google Classroom, and I also have paper version at the school if you'd prefer. Let's get started with this. The objectives for today are going to be identify tangents, secants, and chords. And then we'll use some properties of tangents to solve problems. Okay? So this lesson, I guess, is lines that intersect circles. And my guess is that some of these words are new to you, not chords, I'm sure, but tangents and secants, to actually know exactly what those mean relating to geometry. So we have a whole bunch of vocab: interior of a circle, exterior of a circle, chord, common tangent, secant, pointed tangency, congruent circles, concentric circles, tangent circles, and tangent of a circle. Let's get started. I think you knew this one. The interior of a circle is a set of all points inside the circle, and the exterior of a circle is a set of points of all points outside the circle. You should also know what a chord is, a segment whose endpoints lie on a circle. Okay. Secant and tangent, these are lines. I should grab a pen. I want you to note that where a chord is a segment, secants and tangents are lines. And a secant is a line that intersects a circle at 2 points. Okay. So L here is a secant. Tangent is a line and it intersects at exactly 1 point. So I like to think of tangents as just touching the circle, and secants, I think of going through twice. I think of the word second, like second place or whatever. And then the point where the tangent and a circle intersect is called the point of tangency, which that makes sense. So let's see if we can go ahead and identify chords, secants, tangents, diameter, radius, radii. Okay? So chords, in this case, we should have QR, and that's a segment. I'm going to write it as a segment. And the other chord would be ST. Okay? Because both endpoints are on the circle. Okay? And yes, we know that ST is also the diameter, so I'll just go ahead and put that in there. Secant, now this is a line, and it has to go through 2 points of the circle. So it's line ST. So you just have to be careful about how you label it. Where this was just segment ST, this is line ST. Tangent, that's going to be where it just touches it once, so that's line UV. We already did diameter, and now radii, there's a few of them. So I just like to start at the center and do PS, PQ, and PT. Okay, I think I got everything on here. Let's move on. So pairs of circles. 2 circles are congruent circles if and only if they have congruent radii, which makes complete sense. And concentric circles are coplanar circles with the same center, so could look like this. 2 coplanar circles that intersect at exactly 1 point are called tangent circles. So as you can see, here's an internally tangent circle because they intersect right here and one circle is inside the other. And then externally tangent circles, one is not inside the other, but they have a tangent point right there. All right. So let's find the length of each radius, identify the point of tangency, and write the equation of the tangent line at this point. Now, the way I think the ones in your assignment are similar to these two, where the line of tangency is going to be either a vertical or a horizontal line. So if you remember, a vertical line is going to be x equals something, and a horizontal line is going to be y equals something. Okay. So let's take a look and do this. The radius of circle R. Well, I'm just going to count. The radius is 2. The radius of circle S. Now, that's 1.5. The point of tangency, where they touch, that would be -2, 0. And then the equation of the tangent line, well, the tangent line is actually right here. It's actually the x-axis, if I could draw it. And so that's a horizontal line at y equals 0. And that's what I'll write, y equals 0. Let's do another one. So the radius of circle C is just going to be 1. The radius of circle D looks like 3. The point of tangency is right here, which is 2, -1. And this, they actually drew your tangent line, and that is a horizontal line. So it's also going to have an equation of y equals, and it's actually at y equals -1. Okay, here's a little bit more terminology. Common tangent is a line that is tangent to two circles. You can have internal tangent lines, like this one right here, and you can have external tangents, so like this. Here's some theorems. If a line is tangent to a circle, then it's perpendicular to the radius. Okay? So that because it tells us that line L is tangent to circle A, that means that it is perpendicular to segment AB, the radius. And vice versa. So this is just the same thing. If you have a radius that's perpendicular to a line, then we can be sure that that line is actually tangent to the circle. This question here, I actually have a really hard time drawing these out, but you do have one question on your assignment, so I thought I would do this one, and they already have it drawn out. So the one on your assignment will be similar as well. But we have the tallest mountain in Africa, right? It's 19,340 feet tall. So that would be this part right here, because we're assuming this is the Earth. And I think in a different part they mentioned that the radius of the Earth is roughly 4,000 miles. Okay, but this is 19,340 feet. And it says, what's the distance from the summit of Kilimanjaro, right here, to the horizon, which is right here? So we're looking for this length. And we have a right triangle because we have perpendicular, because EH is tangent. So what we need to do here is actually change 19,340 into miles, so we know how far this is. Because this is 4,000, and this is a radius as well, that's 4,000. So we're going to have 4,000 and plus whatever our height of Kilimanjaro is, but we need to change it to miles. So I'm going to take 19,340 and I'm going to divide by 5,280. Of course, I'm not going to do that by hand. I think I have it written somewhere. Yep, it's 3.66 miles. Okay, which means this length here, my hypotenuse, is going to be 4,003.66. Okay, so all we need to do is use the Pythagorean theorem to find EH. So this is my hypotenuse, so I'm going to set it up. 4,003.66 squared minus 4,000 squared. And whatever I get there, I need to take the square root of. So the final answer is about 171 miles because I just wanted to the nearest mile. Last thing we're going to do is learn about this theorem. If you have two segments and they're tangent to the circle from the same external point, so these are both tangent to circle P at point A, then the segments are congruent. And that's a theorem, and we can use that. So AB and AC are congruent. So that works really well in these two problems here. And we are going to get to a third that's very similar to one on your assignment, so you'll want to listen to that one. But these two are pretty simple. You're just going to, because it tells you they're tangent, we know that each of those sides are equal to each other, so we're just going to set them equal to each other. Okay, did I do that right? All right, so 36 equals 3a, so a equals 12, and then I just need to plug that back in, which is 28, I believe, is the answer, so that you can get the actual length of G and H, or GH. This one is very similar. It tells you the lines are tangent, and so n plus 3 equals 2n minus 1. Same thing, I'm going to have 4 equals n, and then I'm just going to plug it in. It looks like 7 is my answer. Okay, this one here, number 26 is very similar to this. I just wanted to point it out because I think kids have had difficulty seeing this before. So it tells us that PR and PS are tangent. Okay? What we know then from the theorem is that if it's tangent, then it is perpendicular to the radius. Okay? So we have to find the degree of angle P, which is just x, but we now know enough information so that we can set it up. We know that this 90 and 90, and we know this is 3x and this is x. And we know if we add them all up, this should be 360 degrees because it is a quadrilateral. So you're going to have x plus 3x, so 4x, plus 90 plus 90 equals 360. And then you're going to solve that. I believe I end up with 45 degrees for x, and that's what they wanted. So let me know if you have any problems on this one. Have a great day.